All right, this is video number 4. We're doing example number 4 here of the side angle side lesson. So we have a regular hexagon. That's going to be very important for this proof. Okay. And we want to find two triangles within this hexagon that are congruent. Okay. So first off, a regular hexagon means that the side lengths of the hexagon are all the same, they're all congruent, and the interior angles are going to be congruent as well. All right, so let's try to approach this as a two-column proof. Statements and reasons. Okay. And we anticipate there being 4 statements. The first one for a pair of sides, then a pair of angles, then another pair of sides, and then the 4th statement is going to be about the triangles. Right. So you can probably see which triangles, well actually there's a bunch of triangles that we could use, but I think the one that they want us to use is this triangle here, which I'll color yellow. And then this other triangle here. Okay, I guess I'll color it in. Okay, so we've got that yellow and that orange triangle. We want to show that they're congruent. All right, so can we find 2 sets of congruent sides and the angle between them congruent as well? Okay. So I'm going to start by saying that the side AF is congruent to the side ED. And again, that's just using the definition of a regular hexagon. Okay, these are both sides on the perimeter of the hexagon, okay, of the regular hexagon. All right. Next, I think I want to say that this angle here is going to be congruent to this angle here. Okay. Again, because a regular hexagon, all the interior angles would be congruent as well. And then finally, I want to say that the segment EB and FC are congruent. I can see that EB stretches the entire distance across the hexagon. You can kind of think of it as the diameter of the hexagon almost. And FC does the same thing. It stretches across the widest part of the hexagon. So EB is congruent to CF. Okay. And so with that, we should have our pattern, right? Side, angle, side, side, angle, side. And so now let's just record all that work that we just did in the diagram. Okay, so we started with AF and ED. And we're just using the definition of a regular hexagon. Okay, all the sides are going to be congruent. Okay. And then let me just number this angle number 1 and angle number 2, just to make it easier. So angle 1 congruent to angle 2. And again, we're just using the definition of a regular hexagon, right? All the interior angles will be congruent. And then lastly, it was FC and EB. Okay, and again, just definition of a regular hexagon, right? This kind of diameter segment is going to be the same length no matter which diameter we use. Okay. All right. So now let's name the 2 triangles. So I'm going to start here at A and then go to F where the angle is and then go to C. Okay, so triangle AFC. Okay. And then for the orange triangle, I would have to start at D, right? A and D are corresponding points on these 2 triangles, so D, E, B. DEB, and then side angle side theorem. All right, we've got one more video coming up, and I'll see you guys over there.